Hi, this is Mrs. Soares. Today we're going to look at the Evidence for Chemical Change lab. You have this lab on your Google Classroom, so as we're watching what's going on with this particular experiment, you can take notes or you can fill in the Google Doc as we go. So the introduction of this lab talks about how substances such as elements or compounds may undergo chemical change or may be created by chemical change. The substances that undergo chemical change are called reactants. Those are the substances that actually react with each other and cause something to happen to produce new products. And those new products have different properties than the original product, than the original reactants. Clues that you can look at include the formation of a precipitate. Well, that's a solid that you get after you mix some aqueous solutions together. Or did you see any tiny bubbles? That's the formation of a gas. Was there a color change? Now, color change in and of itself is not always the best indicator that a chemical change happened, because sometimes, for instance, if I put lemonade powder in water, that's not a chemical change, but there is a color change. Really, color changes need to be accompanied by something else. Usually the evolution of heat or light, which is an indication that a chemical reaction is taking place. So you have those four major clues, indications, which again are the evolution of heat or light, the formation of a precipitate, the formation of a gas, and a color change. So today in this lab, we're going to see which indications we actually get. So the first thing we need to do is take a 250 milliliter beaker and fill it roughly halfway up with water and start it to boil. And as you can see here, I already have that set up. We are going to be increasing the temperature so that this water starts to boil before anything else happens. Now, as that water is boiling, I need to take a large test tube, and I have one right here, and I need to measure 3 marks with a ruler. One at 1 centimeter, one at 2 centimeters, and one at 3 centimeters. And by marking this, I have my measurements. So this is basically what I'm going to be using to measure. Now, according to the procedure, I need to add to the first line some copper nitrate. It's this really cool blue substance, and I'm going to just add that to the first line. There we go. Now, according to your lab, you want to make some observations. So you want to actually see what this looks like. Now, in order for us to, kind of hard for me to show you this, but because these solutions are at room temperature and the thermometer's at room temperature, the temperature isn't changing. It is 21.5 degrees Celsius. So you can record 21.5 degrees Celsius on your lab sheets. Now, the second chemical that we're using is this clear, colorless solution. It's called sodium hydroxide. So I'm going to add sodium hydroxide to the second line. And I don't know if you can see that, but a nice gelatinous precipitate just formed. So here we have a nice gelatinous precipitate. You can kind of see, if I tip it on its side, you can see the liquid here and this blue precipitate looks like a blue cloud in the solution. So now that we have this, I'm going to take its temperature again and see if there's an increase in temperature. And the temperature does increase slightly. So that means that there's an evolution of energy. The temperature is starting to stabilize at 23.0 degrees Celsius. So we went from 21.5 degrees Celsius to 23.0 degrees Celsius. So when I mix these two compounds together, we got some kind of energy increase. Now, I'm going to put this inside the beaker. We're going to leave this in the beaker until there's no more color change. As you can tell, there's already some kind of a change there. We're getting a little black, powder blue. We definitely have some changes going on. So let me just sit that in there until no more change occurs. So again, let's just take a look at this. We have some more blue, powder blue forming, and we've got a lot of black precipitate forming. Well, what's happening here is the copper nitrate and the sodium hydroxide formed new products. That precipitate that we formed, that gelatinous blue precipitate, was copper 2 hydroxide. Now, as I'm heating this up, I'm decomposing, I'm breaking apart that copper 2 hydroxide and actually making copper oxide and water. So as this progresses, we're going to get more and more copper oxide, which is that black precipitate. So now that it's been a couple of minutes, we can now see that all of this precipitate is black. I'm going to let it sit just for a little while in a test tube wrap. So let me move this out of the way. Put the test tube wrap in your line of view. So here's our substance. You can see that the black precipitate has settled at the bottom and there's a clear liquid floating on top. Well, that's the water. And down the bottom is the copper oxide, which is that black precipitate. The last reactant we're going to add here is hydrochloric acid. We're going to add that onto this one up to the third line. Oh, notice what's happening here. We're starting to get a blue solution. Stir this around. All the precipitate is dissolving back into this solution. So the copper that was in copper oxide, that solid precipitate, once it goes back into solution, it creates this bluish substance. Now, the last part is to take a piece of aluminum. I'm going to just drop it in there. I'm not sure if you can get a clear view of this. but we have some bubbles forming around the aluminum wire. I'm going to pause the video for just a minute so that when you come back, you can see what's going to happen with this. So right now, you should be seeing the bubbles and something forming around the aluminum wire. Okay, it's been about a minute. I think one of the observations you can make is that the color of the solution has gone from a bluish color to a bluish green, and there's more precipitate around the aluminum wire. Now we're going to give this about 20 minutes. I'm going to pause the video so that when we come back, you'll see what this looks like in 20 minutes time. Look at this. We have a much lighter color in the solution, and we've got much more precipitate around the wire. Now take a look at that color. The color of that precipitate around the wire is kind of like a salmon color. What we actually made here was copper. The copper that was in solution actually precipitated out of the solution, and the aluminum replaced the copper, making aluminum chloride. Then we had little bubbles forming there as well. Now you're going to see that the little bubbles was actually hydrogen gas generated from the hydrochloric acid. We still have some bubbles going on here, which means that this reaction is not 100% complete yet. So I'm going to put you on pause just for a little bit longer so that you can kind of check this out when it's totally complete. Okay, now that it's been about 20 minutes, we can take a look and see what we have here. So if you notice, we've got an awful lot of copper on that wire, and the liquid is a little bit clear. And that's because we made water. Water is clear. I know it's really hard to see on the video, but that's exactly what we have. So what I want you to do is go onto your Google Classroom if you haven't already done that. You should have the observations all written down so that you can fill in the lab report. There are some post-lab questions that you need to answer. From the procedure, you can answer all of these post-lab questions. Once you're done, you can turn it in on Google Classroom. Please make sure that you have all of your questions answered before you turn it in. If you have any questions, please email me at soarsc@sbregional.org. See you in class hopefully soon.